Today, we talk about USB HID communication between Windows and STM32. This is a very practical solution for driverless USB communication, and it is widely used in embedded systems. Before focusing on HID, let's briefly look at USB device classes. There are several common types, such as HID, CDC, MSC, and WinUSB. Human interface device enables driverless communication and is widely used for simple control. Communication device class emulates a virtual serial port, making data exchange easy. Mass storage class allows the device to appear as a removable disk. And WinUSB supports custom vendor communication without requiring kernel driver development. Among these, HID is often the simplest way to get started. Now, what exactly is USB HID? USB HID was originally designed for devices like keyboards, mouse, and game controllers. Its biggest advantage is that operating systems like Windows already include built-in drivers. So, when you plug in the device, it works immediately. No installation is needed. This plug-and-play feature makes HID very convenient and easy to use, especially in embedded development. In practice, embedded HID devices usually have three common forms. The first is standard HID mode, where the device behaves like a keyboard or mouse. In this case, the operating system takes control, and applications typically cannot access the raw data directly. The second is vendor-defined HID mode. Here, developers define their own data format using something called a report descriptor. This prevents the device from being treated as a keyboard or mouse and allows the host application to directly read and write data. In most real projects, this is the preferred approach. The third is a composite HID device, where one device contains multiple HID interfaces. Now, an important concept here is the report descriptor. The report descriptor defines the structure of the data exchanged between the device and the host. It specifies the format, size, and meaning of each data packet. In other words, it tells the operating system how to interpret the data correctly. When a USB HID device is connected and enumeration is completed, the Windows HID driver will automatically read and parse this descriptor. So, the report descriptor is essentially the core of HID communication. Next, let's move to the PC side. On Windows, we can develop a USB HID host application using C# with HID#. A HID device represents a device that has already been detected by the system. It is mainly used to identify and open the device, but it does not handle communication itself. The actual data transfer happens through HID stream. This is the object that manages the underlying read and write operations, including input and output reports. To find the correct device, we usually filter by vendor ID and product ID, also known as VID and PID. Once the device is found, we call Open to obtain a HID stream. After that, we can start communication. When sending data, it is important to follow the defined HID packet structure because HID is a structured protocol based on the report descriptor. For receiving data, we typically use a dedicated thread that continuously performs read operations. This ensures that incoming data is handled in real time. Now, there is a detail that is often overlooked, which is device lifecycle management. When closing the device, you must make sure that the reading thread has been safely stopped. This is a very common issue in practice. After understanding the PC side, let's briefly look at the STM32 firmware side. First, we usually define the device as a vendor-defined HID instead of a standard keyboard or mouse, to prevent Windows from interfering with the data. Second, the report descriptor must be carefully designed because it defines the entire communication structure and behavior. Third, we should use fixed-length packets with proper padding so that data parsing remains stable and predictable. Finally, we need to handle VBUS detection and USB enumeration timing correctly so that the device can respond properly when it is connected to the host. Now, let's summarize. USB HID enables driverless communication by emulating a standard HID device. It has low development complexity, high compatibility, and works reliably across platforms. It is especially suitable for small data transfers and simple control applications, and it provides a good balance between simplicity and stability in both hardware and software.